PythonBPF, writing eBPF programs in pure Python. We are the authors Varun R. Malya and Pragyan Chaturvedi. How it all started. We set out to make a better Python alternative to the current Frankenstein of a BCC. As you can see, the kernel space C code is embedded in multi-line strings inside a Python program that does not allow us to take advantage of the Python LSPs, type checkers, and is in general ugly. We set out to fix this. Our goal was to make a Pythonic frontend for BPF with a reduced Python grammar, which is easy to learn and can use existing developer tooling and can become a drop-in replacement for BCC. How we shaped Python BPF. We took inspiration from the syntax of Fast API and heavily used decorators to let our compiler know what it had to compile as well as what kind of component it was. Global data structures are defined as funcs under decorators. Take a look at the comparison between Python BPF on the left and BCC on the right. The difference is night and day. One supports clean and intuitive syntax, and the other needs one to take a long, hard look even to understand what's going on. This improves developer experience as you, the developer, needs to understand only one language to write BPF programs now. No more fancy C. Allows all Python dev tooling to work, and this also opens up new avenues in kernel event data processing and using Python notebooks to write eBPF programs. We have provided extensive support for Python notebooks to enable this. Python BPF works by generating the AST using the Python AST module, walking the AST, and emitting LLVM-IR using LLVM Lite and our processing logic, and then getting compiled to bytecode by the LLVM BPF backend. We can beat BPF trace too. Now, no one has to learn a domain-specific language to do their tracing. All they need to do is spin up a Python interpreter and everything can be written in Python. Now I'll be showing you the demo of one of the tools we have written in Python BPF. This is a tool that uses Python BPF and its sister library PyLibBPF, the libbpf bindings we wrote to get container statistics by monitoring C groups. We first spin up a Docker container and open its C group to see its statistics. The Docker container is up, and we can navigate the TUI. As you can see, the file IO updates as soon as I make changes because it's writing to standard error and standard out. You can see that we receive network information as well, and there's read and write information. There is a web version too. It looks like this. This is all wipe coded within an hour on top of that. This demonstrates the power of the Python ecosystem. Coming back, while the examples are AI generated, Python BPF itself could not be wipe coded. All of this work is as human made as it gets. What we plan to do next. We want to support all eBPF helpers, add full kfunc support, add XDP support as well as ShedX helpers. We will also continue to port examples and tools such as Netflix's BPF top soon. Our vision is to turn Python BPF into a gold standard for writing eBPF programs instead of looking to C or Rust's AYA. Writing things like a neural network scheduler would become a piece of cake when this is accomplished, as the Python ecosystem is quite mature in terms of data processing like this. We need you to help us make this a complete reality. While some of the work is completed, a lot of it sadly remains. Two people aren't really enough to build a full compiler toolchain. We'd love to see contributions to Python BPF and suggestions for tools to be ported over. Thank you for listening to us, and please star our repository at this link.